Hello again, it is I, Derek from Tomcat Gas Training, and welcome to this video which is part 2 of the unsafe situations quiz. But as usual, before we get into this video, you know the drill by now, please could you take some time to subscribe, don't forget to give me that thumbs up, and if you've not hit that notification bell, then get it hit. So, without further ado, waffling and messing around, as usual, let's just get on with it. Now let's start off with a nice easy one for you. This picture represents you going to do a tightness test before any gas work where you're going to be breaking into the gasways. So as you can see, we've got something missing within 600 of the metre or before the first branch. So what would you categorise this as? Your time is up, so let's get on with it and find out what the answer is. So from IGEM G11 edition 2, you can see it's 3.19, equipotential bonding not installed or inadequate, e.g. not secure. Electrical issue, see clause 332 in this procedure. We'll have a look at that in a minute, but then it also says see right. So let's see what see right means. So if we do look right, it says leave a bonding notice informing the responsible person that the equipotential bonding work should be checked or carried out by an electrical competent person. For further guidance, see Gas Safe Registered Technical Bulletin 102. So basically, we're classifying this as NCS, not to current standards. So let's find out what this 332 is. Now, the IET wiring regulations and British Standard 7671 and the Gas Safety Installation and Use Regulations 1998, which was amended in 2018, states that gas pipes should be earth bonded. Now, let's read you this 3.32 from the IGEM G11 unsafe situations procedure. It says, Regulations 18.2 of the Gas Safety Installation and Use Regulations place a duty on a gas engineer to notify the responsible person that equipotential bonding may need to be connected to a gas installations in domestic premises. So basically what it's saying is, if you rack up to somebody's house and there's no earth bonding, because we are not electricians, we need to let the responsible person or the homeowner or the landlord or whatever that we need earth bonding. And I'll show you what we need to do in a minute with that. But there is a note here. It says where non-metallic, non-conductive, e.g. PE, service pipes, service pipelines enter the building and then connect to metallic pipes within the building, the metallic pipes within the building do not require protective bonding. So this is where gas engineers and electricians kind of say earth bonding is not needed if we've got plastic pipe coming in, our gas pipeline is plastic coming into the property. But that's all well and good if you've got MCBs and RCDs, so miniature circuit breakers and residual current devices. Then if anything happens and you've got straight current, then they'll trip. But we've got no protection when we're cutting into a gas pipe. So if there was a stray current or voltage going through this gas pipe, then we could create a spark and could create an explosion. So we should be using our temporary continuity bonds to protect us, and obviously our non-contact fault indicator. But why doesn't it need earth bonding now? That's what I don't get. Anyway, I will read on. It says, where required, the purpose of equipotential bonding is to ensure that gas installations, other metallic services and parts within the premises remain safe under electrical fault conditions. Makes sense? Where bonding is necessary, it should preferably be connected within 600 mil of the outlet of the gas meter before the branch, or where the meter is fitted outside the building as near as points to each entry of the pipework. inside the building before any branch. So if you have got an outside meter box, then if you can see the gas pipe on the inside, you put it on the inside rather than the outside. Straightforward. Where a gas engineer cannot confirm that adequate bonding arrangements were necessary or exist, HSE guidance is that the responsible person be notified in writing of the requirement of equipotential bonding. This can be achieved by leaving a bonding notice as described in BS 6891, which advises that the bonding be checked, carried out by an electrical competent person. So do we need to put bonding on or don't we need to put bonding on? Well, because we're not electricians, we just need to make the customer aware, and then we need to make sure that we're checking there isn't a stray voltage with our non-contact voltage indicator, and we also need to use our temporary continuity bonds to keep us safe. Is that fair? If you disagree with me, put it down in the comments down below. But what is this notice then? So we advise and we carry these stickers, which you can buy off the internet, which you will leave at the gas meter. So you can either stick it on the meter if you want, or you can stick it in the meter box if it's outside, as long as it can be read and easily seen by the person in charge, the owner, the tenant, the landlord, whoever. So that's what we need to use. We need to use one of these electrical bonding notices, because remember, we're not electricians, we're gas engineers. So let's have a look at the next one then. So this short video clip shows an engineer confirming that there is let-by on an ECV while carrying out a tightness test, but there is no smell of gas within the property at all. So how would we categorise an ECV passing with no smell of gas? Your time is up, so let's get on with it and find out what the answer is. So according to IGEM G11 edition 2, it's 3.7. It says let-by on an ECV without the smell of gas, we would categorise it as at risk. Did you get that one? But obviously if there was a smell of gas, then we would be deeming it as immediately dangerous, because we wouldn't be able to turn off the gas to stop the smell or the leak. So how do we deal with this situation? So let's go across to the other side of the book and find out what we should be doing. Now the other side of the page says, notify the gas emergency contact centre, or in the case of LPG, notify the gas supplier. It then says see contact list on table 2, which is at the front of the book and gives you all the phone numbers. It then says make safe as described in IGEM UP1 series of procedures. So basically if we had a cap for the ECV, we would be putting that on, or we could even be reconnecting the anaconda and then ringing Cadent or the LPG supplier to come out and change the ECV before we would be allowed to do any work on it, because there was no smell of gas. Obviously slightly different if there is a smell of gas, and Cadent will have to act a little bit quicker than they normally do. So did you get that one? Well, let's have a go at the next one then. Now this next scenario represents you going to do a service of a new condensing boiler. And because you go through into the living room, and according to IGEM G11 Appendix 5, you have actually encountered this gas appliance, you see this staining above the top of this radiant gas fire. So, what is this staining, and what would you classify this situation as? Remember, you're not there to work on this fire, you're there to work on the boiler. Your time is up, so let's get on with it and find out what the answer is. Now according to IGEM G11 page 21 1.5, where no work is being undertaken on an appliance but there is visual signs of spillage or leakage of products of combustion from the appliance and or chimney flue, and there is no evidence that the problem has been corrected, we must class it as ID. So that means we would have to investigate it, and if we didn't have time to investigate it, we must disconnect from the gas supply with the customer's permission, issue a warning notice and stick on our sticker. And if the customer refuses you to disconnect it from the gas supply, then you must get in touch with Cadent and they'll come and do it. But that's how you would deal with what you would think is signs of spillage. Now this picture represents you going to do a landlord's report. And when you're doing your visual inspection of your pipework, you find this gas pipe is installed right next to a plug socket. So, what would we categorise this as? Is it at risk? Is it ID? Or is it just not to current standard? Or do we really not give a monkeys because it's just an electrical socket next to a gas pipe? So, how are you going to categorise this one then? Your time is up, so let's get on with it and find out what the answer is. Now, looking through IGEM G11, you won't find this scenario anywhere. So if you can't find the scenario in here, then basically you can class it as not to current standards. So how far does a gas pipe need to be away from a plug socket? Well, it's 25 mil away from a plug socket or an electric cable, or 150 mil away from a consumer unit. Is there anything we could do in this situation? Well, we could protect the gas pipe by using electrical tape and go 25 mil above and below the socket. Well, that'll look a bit shocking. Is the gas pipe showing any signs of damage or corrosion? No, then it's not to current standards. But you would note it down on your paperwork that it's too close to the socket and it should be moved, because it'd probably be easier to move the gas pipe than it would to move the socket. Let's have a look at the next one then. Now this picture represents you going to do a landlord's report and you find there is a flueless space heater. Now the flueless space heater passes all its tests, including its flue gas analyzer test, but you find this ventilation, which is also the correct ventilation, installed in this location in close proximity to this flueless space heater. So how are we going to classify this? Not to current standards, at risk, ID, and do we even need to RIDOR it? So which one are you going to choose? Your time is up, so let's get on with it and find out what the answer is. So you can find this on page 38 of IGEM G11, paragraph 9.6. Flueless space heaters installed in a room or internal space where the air vent is incorrectly positioned, and we will be classifying it as at risk. Did you get that one? So there's some notes to the side which I think we need to know, so let's have a look at these notes. So the notes say refer to the manufacturer's installation instructions and BS 5871 part 4 for the correct positioning. For further guidance, see Gas Safe Registered Technical Bulletin 088. So basically what they're saying now is these vents need to be at least 1 metre away from the appliance. So that's what they're saying. So if they're not 1 metre away, then you're at risk in it. Now, why is it important that these vents need to be at least 1 metre away from a flueless space heater? Well, basically what they're saying is, or what they have found over the years of having these appliances, is that if the vent is too close to the appliance, it can keep the ASD working, so it can supply the air for combustion and keeping the ASD on, but it can actually vitiate the room. So that's the main reason why these vents need to be away from the appliance of a metre. They also say split them 50-50, so if you need 100 centimetres squared up to 2.7 kilowatts, split it 50-50, one high, one low. Less chance of them getting blocked and age, convection and all the rest of it. I've got loads of videos on flueless space heaters, so have a watch of them. So that's why they need to be 1 metre away, so the ASD or the atmospheric sensing device doesn't stay on if the room gets vitiated. Let's have a look at the next one. Now this picture represents you going to do a tightness test on a landlord's report. So this is the meter you're confronted with. This meter is installed inside the property. So is there anything wrong here? And how would you classify this? Is it at risk, ID, or not to current standards? or what even is the fault on this installation, if there is one. So how are you going to classify this, guys? Your time is up, so let's get on with it and find out what the answer is. So page 23, IGEM G11, 2.9, medium pressure or higher fed meter installation located within a domestic premises. We will be classifying this as at risk. How many of you said it was ID? Anyway, we've also got some notes, so let's have a look at the notes. So in these notes it says, in all cases inform the relevant gas transporter or gas supplier as appropriate, who will send a competent person to site to undertake further investigations. For further guidance, see Gas Safe Registered Technical Bulletin 003. Now this picture represents you going to service a boiler and you found that another engineer has bypassed this high limit stat. So what would you do in this scenario? Would you at-risk it? Would you ID it? Is it just not to current standards? Or should the engineer be ridored also? So guys, how are you classifying this one? Your time is up, so let's get on with it and find out what the answer is. So IGEM G11, edition 2, page 35, 7.4, appliance gas controls and safety devices that affect the safe operation of an appliance, which are inoperative, failing to danger, or are disabled. We would be classing this as ID. So did you put ID? Well, let's have a look at these notes and see what it says there. So these notes say examples of devices include flame supervision devices or FSDs, regulators, spillage monitoring systems, e.g. TTBs or ASDs, air pressure switches and high limit thermostats, etc. So that's why this has become ID, is because it's been bypassed. But because it has been bypassed, we should also be ridoring the engineer who's bypassed this safety device and left this boiler running. So as well as being ID, this is also ridor reportable. Now let's finish off with this picture and let's see exactly how many faults you can find with this open fluid boiler, if there are any faults that is. So give you a few seconds to have a look and see what you can come up with. Your time is up, so let's get on with it and find out what the answer is. Now, how many faults have you spotted behind me here then? Shall we start at the bottom here on the above the draft diverter? Can you see that the actual appliance adapter isn't sealed to the draft diverter? So that's the first one. Next one, not 600 rise to the first bend. What angle have we got on the bends? So we've got two 90-degree elbows, which is not allowed. Have you noticed the damage on the 90-degree elbow where it's showing signs of spillage? Have you noticed it's painted as well? And also the signs of spillage on the wall as well. So what are we going to classify this as? Let's take the faults on the Flue system first. So we've got not 600 rise, we've got 90-degree bends, we've got painted, and we've got damage. Okay. Now all these different scenarios, obviously as long as products of combustion aren't coming into the room, we will classify them as at risk. So IGEM G11, page 31 it is, and it's 5.9, it says, existing open flue chimney systems installed with one or more defects likely to affect the safe and effective performance of the chimney and flue system. And it says we will classify them as at risk. Now on the notes it says, Examples of installation defects likely to affect open chimney flue performances include, but are not limited to, inadequate vertical rise to the first bend, so they're not 600, inadequately supported, well you can't see any clips on this, 90-degree bends, yeah, we got two 90-degree bends, non-compliant termination position, well you don't know where that is, incorrect use of chimney flue material, e.g. exposed chimney flue liner. So if you do go to an open flue boiler and there's flue liner on show, that's also at risk. Inadequately sized chimney flue pipe, it's the right size. And unsuitable terminal fitting. Again, you can't see the terminal. At the bottom it says, where one or more such defect or defects is or are identified, the engineer shall assess the safety of the gas installation and decide whether the deficiencies are so serious it warrants the installation being classified as at risk or AR. What's our big problem? We've got signs of spillage. So what does that make it? Yeah, it makes it immediately dangerous. I think if you racked up to this boiler and you saw it in this state, hopefully you would be IDing it. And obviously if you did a flue flow test and spillage and found out it was failing, then it would be definitely ID. So that's our final one for this quiz. Did you get it right? Well, if you did, hopefully because of that you're going to give me a thumbs up because you like this video, and if you've not subscribed to our channel then please subscribe because it helps. And again, don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos. Mondays and Wednesdays normally. All I've got left to say is, thanks for listening, thanks for watching, and if you do want any more of these or you're getting bored now, put them down in the comments below. Catch you on the next one, guys. Cheers.